Jai Hind everyone. I am Achintya Pandey, as an assistant professor in Department of IT at Ajay Kumar Garg Engineering College. So today we will discuss OSI reference model for communication between two systems. Okay. Okay. To explore the OSI, Open System Interconnection reference model. So what is OSI? OSI stands for Open System Interconnections. So the communication between two systems are what could be the reference model to communicate between two systems. Okay, so basically the OSI reference model is used, and that is this reference model is basically divided into 7-layer task. Okay, let's compare the communications. Why we have divided, why the communication between two systems been divided into layer task. So we use the concept of layers in our daily life. As an example, let us consider two friends who communicate through postal mail. Just like two friends, okay, they communicate through postal mail. So what process is being adopted, or what process should be adopted to communicate between two friends? The same analogy is applied between two systems. Okay, and by that the model is being proposed. The process of sending a letter to a friend would be complex if there were no service available from the post office. Okay, if two friends want to communicate, someone is sitting say India or in North India, and someone is say South India. Okay, so how they could communicate? Okay, so in the postal services, for example, say this is sender and receiver. So how this communication can be divided into different layers. Okay, and by using the this concept, by using this concept, we can implement even for the system. Okay, so first, say sender wants to communicate with the receiver. Okay, so this is the layer, higher layer, middle layer and lower layer. The letter is written. Okay, sender, say the letter is written, put in an envelope and dropped in a mailbox. This sender, the primary job will be like in postal mail system, and this is done. So then what after putting or what after dropping the letter into mailbox? The letter is carried from the mailbox to a post office. Okay, then the letter is delivered to a carrier by the post office. Okay, now the parcel is carried from the source to the destinations. Okay, now and in the receiver side, the letter is delivered from the carrier to the post office. Then again in the middle layer, the letter is carried from the post office to the mailbox, and finally the receiver, the letter is picked, removed from the envelope and read. Okay, so these processes are the task which is involved in sending a letter, are say divided into different layers. Okay, so why do we layering? Why layered is basically just to modularize the task. Okay, and these modularizations can be specifically implemented either by the hardware or by the software. Okay, so this is higher layer, middle layer and lower layer. Okay, so just as a postal system, how a friend or two party communicate with each other, the same analogies can be applied, the same analogy is being applied to communicate between the systems. Okay, so OSI model was the proposed, which is proposed in stabilized in 1947. Okay, and this OSI reference model is basically a reference model to communicate between any two communicating devices. Okay, so how it is done? The concepts from postal system is being implemented in this communication model. Okay, so OSI is stabilized in 1947. The International Standard Organization ISO is a multinational body dedicated to worldwide agreement on this standard, and an ISO standard that cover all aspects of network communication. Okay, all aspect of network communication is the OSI, Open System Interconnection model. It was first introduced in the 1970s. So here you have to note that the ISO is the organization while OSI is the model, and this model is for communicating two devices. Okay, how the communication between two system, a device, a node being conducted. Okay, so this reference model is basically divided into 7-layer tasks. Okay, like we have seen in the postal system, the communication between sender and receiver is being is being categorized into 3 layer: higher layer, middle layer and lower layer. Okay, so here the communications and in the OSI reference model, the task there are mainly 7-layer tasks. Okay, and that layer is physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. So OSI is a reference model, while TCP/IP, this is the practical model. Okay, which is implemented. Okay, in the TCP/IP there are basically 5 layers. Okay, these 3 layers being say you can say is integrated into 1 layer, and that is called application layer. The functionality of all these 3 layers is just being integrated into 1 layer, and that is the TCP/IP layer, which is the real one. Okay, which is implemented actually. Okay, so in TCP/IP we have there are 5 layer, and the name of the 5 layer will be physical layer, data link layer, network, transport and application layer. Okay. Okay, so let's see what are the functions of these 7 layers, so that things could be categorized. Okay, so for example, let's say device A and another side, a receiver side, device B. Suppose system A or one device wants to communicate with the say other devices. So how this communication could be done, what could be the model? So just to establish or to complete the communications, these 7 layers are, you know, all the functionality are to communicate, or you can say which is involved in the communication from device A to device will be within the physical to or you can say application to physical layer. Okay, so at the host side, at the application side, where user could type and something. Okay, this is the application layer. So application, presentation, session, transport, network layer, data link layer and physical layer. Okay, these all intermediate node. Okay, like router and other devices. Okay. Okay, so at the suppose user type some message, so for that there must be some interface, okay, and that interface will be at application layer. There some kind of browser or whatever, okay, there must be some interface, and that is called application layer. So what protocol and all this involve, it is in the application layer, okay. So at application layer will be responsible for the user interactions, okay. And there are basically some protocol at the applications layer which control coordinate and all things, okay. So user interact with the application layer. Then so every layer, whatever the functionality or modularity we have defined here, okay, so every layer attaches control informations, okay. For example, application layer attaches control information, and that is called header, okay. Similarly, presentation layer attaches some control information, okay, that is also called header. So every layer attach it, every layer depending on its functionality, they attach some header control information, and that control information is the header of that particular layer, okay. Okay, so the data at each different layer is called payload. The data is basically a payload, okay. So sometimes when the data along with say application layer header is called payload, okay. The payload means data and its control information, that is header, data plus header, that becomes the payload. So application layer has, I mean, data and its control information, that is header. Similarly, presentation layer and even the physical layer. So at physical layer, that is close to a network, I mean hardware, okay, just the hardware, okay. Moreover, it is up to the only bit level communication, okay. So bit level functionality, how the bit could travel or how the bit can be, you know, converted into signal and all that in the network. This responsibility is carried out by the physical layer, okay. So there the data will be just as a bit. In the data link layer, attach two control information, header and trailer, okay. So at data link layer, payload, it is called frame. Similarly, network layer, this attach its own header information, and that is called packet, okay. So at network layer, it is called packet. Transport layer, it also attach its control informations, okay, I mean header. So this is called segment or user datagram, okay, datagram or segment. So there are two in the TCP/IP, it is called segment, and in the UDP protocol, it is called datagram, okay. And this application presentation and session layer, you can say in TCP/IP application layer, they attach also control information. So message, here it is called just message. So let's see how this could be done. So you can see at the sender side, whatever user wants to communicate, they will type, okay, I mean message, and for that there must be some kind of message interactions, I mean interpreter, okay. So data, so you can see that application layer attach its header, say for example at 7th layer, this is H7. Similarly, presentation and session layer, they attach H6, H5, okay. This is transport layer as a header H4. This is network layer, and they attach its own header, and that is called H3, 3-layer, third layer, okay. And data link layer, they attach two control information. One is header, second is trailer. And we are just seeing when this comes under physical layer, this whole things become only in the bit, okay. And now this bit, that is, you can say this is close to hardware, okay. So when this bit will be in the medium, they become into the signal. So from bit to signal, okay, whatever the process, encoding and all the schemes will be used, okay. That is the part job of the physical layer, okay. Similarly, at receiver side, so sender side, they attach header, and just to decode the exact informations, just to decode the message at the receiver side, these layers, I mean physical, data link, network, transport, presentation layer and application layer, they just detach the header, okay, so that at user level it will get the message, okay. So this at the physical layer, the bit will be same, and detach its control informations, I mean header. Similarly, at data link layer, they detach, and finally the message is received on the application layer, okay. So an exchange using the OSI model that could be visualized with this diagram, okay. Now, so layers in the OSI model. In this section, we briefly describe the functions of the each layer in the OSI model. So what physical layer does? So as we have seen, the physical layer is responsible for interaction with the hardware, like signal system, signaling voltage level, pin system and all. The physical layer is responsible for bit, okay, only 0 and 1, okay, and voltage level, I mean hardware related task, okay, and hardware basically, okay. So the physical layer is responsible for the movement of individual bits from one hop to the next hop, okay. So how bit can be converted into the signal while in the network, how this bit could be managed, okay. So this is the job of the physical layer. Now what will be the job of data link layer? Data link layer, basically data link layer has three jobs. One is framing, second is flow control, and third is error control, okay. So data link layer has the responsibility of framing, flow control and an error control. Framing means, I mean say we have fixed size frame, I mean combination of say fixed few bits, say 8 bit, a 16 bit or 4 KB, okay. So we just wrap the bit into the frame, okay. I mean it is just combination of few bits, okay, we can say framing. So now at data link layer, the communications, or you can say everything will be in the form of frame, okay. So framing is just the method to frame the bits, okay, how we can divide the bits into the frames, like first frame, second frame, third frame. This is called framing. So there are some process just to segregate which how this could be first, how this could be second and third and so on. So there are some methods, and that method has character count and like that, okay. Flow control. What is flow control? Is basically say sender has a different speed, or sender has may be fast and receiver may be slow. Okay, so there may be mismatch of the speed. So receiver will, if sender has more speed, I mean sender can send data more faster, okay, and receiver is slower, so receiver will always have, you know, waiting window. Okay, so this should not be there. Flow control, basically this is the technique to control the flow of the bits. Okay, that is called flow control. Okay, so that there could not be any mismatch. Okay, that could be controlled. So we have some I mean there are some techniques, say stop and wait. Okay, sliding window. Okay, they are the techniques. And error control. Error how, say in the medium our bit may change from 0 to 1. So to ensure that the there should not be any error. Okay, so these all are the tasks at the data link layer. Okay, so these tasks basically is done by the data link layer. Okay, so the data link layer is responsible for moving frames. So what is frame? Frame is basically combination of some fixed size bit, okay, or maybe even different size bits. Okay, so the data link layer is responsible for moving frames from one hop to the next hop. Hop means node or any communication device. Okay, so you can see, say here, this is end system, this is another system. Okay, this is another system. So how hop to hop delivery. So in between, say in network there could be many routers. So this is one node, you can say this is another node. So this could be the hop to hop delivery. Okay, so this is the, you can see, from application to here physical layer. Okay, so you can visualize how hop to hop delivery could be occurred. Okay, so network layer. Now this is the network. So we have identified the job of physical layer. The job of physical layer is up to the bit, and the job of data link layer is basically three jobs. One is framing, second is flow control, and third is error control. Okay, next layer is network layer. Network layer, it has basically I mean logical routing. Okay, and how the packets, or you can say logical addressing, you can say here, you can say the job of network layer. One is logical addressing and second is routing. Okay, logical addressing and routing. So this is mandatory service of the network layer. Okay, say in the network there could be so many networking devices. Okay, so if from one hop to another hop, so which route could be followed to communicate from sender to receiver, that is done by the this task is carried out by the network layer. Okay, so this is called routing. So there are so many algorithms which used to decide which route should be best, like DVR, distance vector routing, link state routing, and all that. So these algorithm ensures the least cost route from sender to receiver. Okay, so here at the sender side, data will be from the transport layer to network layer. Okay, so here the data, or you can say payload, will be as a packet. So how a packet from sender to receiver, it just travel through different networking node. This informations or this decision, okay, is carried out by the, or this decision from which routes, okay, that the packets should travel, okay, is called routing. So the network layer is responsible for the delivery of individual packets from the source host to the destination, okay. Like here you can say in the data link layer, what we have seen, message is divided into frames. In the network layer, this data becomes the packet. So message is divided into the packets, okay. So how the packets, because one message is having say 3-4 packets, okay, or n packets. So these, how these packets travel from source to destination via different hop or communication devices is the carried out by the network layer, and they use just the algorithm. There are so many algorithms just to ensure the least cost routing, okay, depending on the conditions are constrained, okay. So the network layer is responsible for the delivery of individual packet from the source host to the destination host. Now next layer is called transport layer, okay. So transport layer basically ensure the end-to-end delivery, okay, end-to-end delivery. The other services of transport layer are even flow control, error control, okay, and the mandatory service is end-to-end delivery. Like just see, this is sender, this is say receiver, okay. So say sender, and this is a router, this is another router, okay. So this is the I mean to communicate from A to D, okay. So this is hop to hop delivery, okay, source to destination delivery. Okay, so transport layer is responsible for the delivery of a message from one process to another process, okay. So say a sender has, or you can say any system hop to hop. What is the meaning of basically end-to-end? End-to-end means process is responsible, a system, and I mean there could be many processes. So process to process communication, from sender process to the receiver process communication, okay, because this sender has so many process, receiver will have so many process. So how this process to process communication is called end-to-end, and that is called reliable and unreliable, okay. So this becomes the reliable process to process delivery, and in the TCP/IP it ensures the reliable process, okay. Okay, so this is carried out by the transport layer, okay. So you can visualize using this diagram, okay. Session layer, the session layer means the task of session layer is divided into say dialog session, make sessions. This is the task of session layer, okay. So the session layer is responsible for dialog control and synchronizations, okay. Presentation layer, what is the job of presentation? Presentation layer is basically responsible for translations, or you can say compression, just to reduce, and encryptions, okay. And this session, presentation and application is just combined into one layer in the TCP/IP, and that is called application layer. So application layer whole has the responsibility to do all the tasks of session, presentation and application layer itself, okay. So you can see here. So application layer is responsible for providing services to the user. How application layer provides the service to the user? That is the job of the application layer, okay. So again you can see this is the task of, we have just summarized the task of each 7 layer. So the task of physical layer is basically to transmit bits over a medium to provide mechanical and electrical specification. Mechanical, electrical specification like voltage level, okay, pin configurations and all that. What is the task of data link layer? The task of data link layer is to organize bits into frame to provide hop-to-hop delivery, okay, one node to another node. Network layer to move packets from source to destination to provide inter-networking, means routing. That you can say the routing is the primary job, or you can say mandatory job of the network layer. Routing is basically to decide the route from sender to receiver. I mean, which paths of the, an internet could have so many routers from one sender to another sender, okay. So which router at the time of communications should be selected while communicating from sender to receivers, okay. So the job is done by the network layer. Transport layer, what is the job of transport layer? To provide reliable process to process message delivery and error recovery. Process to process means sender may be running, sender is running so many process at sender side, receiver may be running so many process. So sender's process and receiver process, how they communicate, okay, and that is called end-to-end delivery, okay. So that responsibility is carried out by the transport layer. Session layer is just used to stabilize, manage and terminate session layer. Presentation layer is basically to translate, encrypt, I mean one form to another form and compress, just to reduce the data. And application layer is to allow access to network resources. I mean how the user interact with the system, okay. So how the user interact with the system, that is job of the application layer, okay. Okay. Now TCP/IP, this is basically real one which is adopted, okay. So the layer in the TCP/IP protocol suite do not exactly match those in the OSI model. The original TCP/IP protocol suite was defined as having 4 layers like host to network, internet, transport and application. However, when TCP/IP is compared to OSI, we can say that TCP/IP protocol suite is made of 5 layers, that is physical, data link layer, network, transport and application layer, okay. And this is the TCP/IP and OSI model, okay. Basically these all are the protocol at these different layers and these all are the layer. So we can say that model is divided into different layers, okay. So OSI, or you can say TCP/IP, this model is this model to communicate from sender to receiver or one communicating device to another device is basically on dividing or modularizing into different tasks, okay. And these different tasks are under these 7 layers: application, presentation, session layer, transport layer, network, data link and physical layer, okay. So this protocol defined by underlying network, host to network, network layer, these all are the few popular protocol which is in the network layer, like ICMP, Internet Control Message Protocol, IGMP, IP Internet Protocol, RARP, okay, ARP, Address Resolution Protocol, okay. Similarly, so this is called you can say protocol suite. This is called protocol suite. I mean at every layer, see these all are the protocol which is used in this layer, okay. So SMTP, FTP, HTTP, DNS, SNP, Telnet, these all are the you can say application layer protocol. What is SMTP? This is simple message transfer protocol or simple mail transfer protocol. FTP, file transfer protocol. HTTP, DNS, domain and system hypertext transfer protocol. SNMP, simple network management protocol. Telnet, ठीक. And SCTP, TCP and UDP, okay. TCP is reliable, UDP is just not reliable, okay. So what is OSI reference model? It is a model to communicate from one device to another device. How we can make a model so that the communication between two devices could be done. So the model basically contain the 7 different layers. Why it is done? Just to segregate the functions, okay, the task at different layers. Okay, if we do layers, so it will be quite easy to implement, okay, rather than whole thing is implemented into a single thing. Okay, so this is all about the TCP/IP and OSI model. Okay, thank you everyone. Jai Hind.